Like that.
Boom. Okay.
Like that. Hey, everyone. Welcome to the Tom's Hardware Podcast for today, July 18th, 2023. As always, I'm Tom's Hardware Editor-in-Chief, Avram Piltch, joined by Associate Editor Les Pounder, Maker Expert Ash Hill, and our very special guest, Massimo Banzi, the inventor of Arduino. Thank you so much for joining us.
Hi, everyone. Thank you for the warm welcome. I'm the co-founder. I don't want that after this interview, I get these emails from my co-founders like, "You're not the inventor, you're the co-founder." I don't really speak with this sounding voice, but the tone is going to be like that. Anyway, thank you for the warm welcome.
Thank you so much for joining us. I know you've had some really obviously huge influence on makers everywhere. How did you get, for those who aren't familiar, how did you get the idea to create Arduino?
Well, so Arduino started off because I was teaching in a design school in the northwest of Italy, and so my class was about teaching students how to use electronics to prototype the devices they were designing. But the students are very, very smart, but they don't have a background in electronics. They're mostly designers or artists, or sometimes there are people who are from the technology kind of world, mostly software people. So the idea was, how do you teach this, enough electronics so that you can be very productive in building prototypes? And so I work with a number of different technologies, and also I built a few platforms in between. I built this thing called Programma 2003. There was an attempt at building something that would be simple, based on a PIC chip. So it's kind of like Arduino, but with a PIC chip. And then I met this. On one hand, one of my students, Hernando Bargan, started to work on a project called Wiring that took that research in another direction. And also I met with my co-founders, David Quartielles. They came over to the school in Ivrea, in the northwest of Italy, to work on a project. Mm-hmm. And so I started to involve different people, and we started to build the platform. And then, based on all these different experiences that we did at Arduino, we did at this school in Ivrea. There were other projects that we did there. One of them was called Instant Soup, that was done by one of my students and one of the other teachers. So we kind of took a bunch of inspiration from all these different projects, and we started to build Arduino because we wanted something that would be open source from scratch. I would say most of these projects that I mentioned, they all take inspiration, and Arduino take inspiration mostly from a platform called Processing, which is essentially a programming language that was invented at the MIT Media Lab to help designer and artists learn how to code and build kind of visual type of application for the computer. So we took a lot of the principles from there, and we translated it to Arduino. So that was kind of the beginning. Then, at the beginning, the audience was about 50 people. So it was the people in the school. Then it became a little bit more people because we involved the students of David Quartielles, and then we involved this other professor, friend of mine, Tom Igo, who teaches in New York. So it started to expand a little bit. Also, me and David spent several months traveling through Europe, sleeping on floors and in all places to kind of do workshops and promote, in a way, the idea. And then it became a tool for makers. At the same time, kind of the maker movement was kind of taking off. This was around 2005, 2006. And so it became like the classic tool for makers to do electronics, because what people used before was either quite limited or it was quite expensive. So in a way, Arduino was reasonable price, it was a good user experience, it was simple enough. I think that's kind of the beginning. the whole project.
So Kevin asks, is it true the name Arduino comes from a shop in Ivrea?
So partially true. It's not a shop. So Arduino comes from the name of a bar in Ivrea. Because when I moved to Ivrea, which is in, I'm originally from the Milan area, and we have this tradition that aperitivo. So after work we go and have a cocktail, and you get some snacks or whatever. And they didn't have it in Ivrea. And then suddenly this bar Arduino started to do it, so it became my regular hangout. And while I was looking for essentially a name for the product, it was me and David sitting in front of the computer. There was this guy on the phone, the PCB guy, saying, "You have to give me the name by 12, otherwise we're not making the PCB." So I said, "You know what? Let's call it Arduino. Let's use this as the name, and then we'll figure out." And in the end, this is how it became Arduino.
That's interesting. I heard a myth years ago that the price of an Arduino was akin to the price of a good meal and a glass of wine in a local restaurant. Is there any truth to that?
I mean, that's a metaphor that I used. I mean, when we started looking at pricing the board around 20 euros, more or less, it was basically because the tools that we were using before, for example, we were using the basic stamp, that once you shipped it from the US, imported to Italy and all of that, it was like 100 euro. And it didn't even have any analog input, So the basic stamp was an amazing tool when it was born, but by the time I started teaching, it was kind of showing a little bit its age. It was expensive in Italy. The students were not very, they didn't experiment quite a lot because they were afraid of burning the chip. So in a way, we wanted something cheaper that we could use to encourage people, and the closest metaphor that I could come up with is if you get a pizza and a beer in a pizza place, is about 20 euros, more or less, depending on depending how fancy the pizza place is. In the south of Italy is less than 20 euros, but in the north of Italy is about 20 euros. So I said, I want the students to basically say, it's the equivalent of a pizza. I have one less pizza and I can buy a board. I didn't want them to feel like they had to be super careful with the hardware, otherwise,
No, it makes total sense, because you're well worried if you buy an SBC for say 200 euros or 100 euros, you are frightened of breaking it. But something that's about 20 euros, if you break it, it's not a great deal, is it?
Yeah, in a way, that was kind of the idea. Also, the original idea that we still manufacture some of the Arduinos with a processor that you can remove, because again, this idea that you could eventually kind of fix it yourself, or you could take the chip and put it in your own product. So there were a number of these considerations in the cost, and I would say one of the probably recurring theme when I talk about Arduino is how being born in a design school means that the technology itself was never a huge focus. It's an 8-bit processor. It wasn't even like the most sophisticated at the time, but the user experience was always the important part. So that's why when you look at the pricing, you look at what's the user experience compared to the pricing, or when you look at all the different parts of the system, what's the user experience and how can we make it simpler and better.
So touching on the user experience, you mentioned that when you first created the board, it was intended for students, and then it starts to grow and expand to the larger maker community. What were some of the early projects that you remember that stood out that maybe you didn't expect people to create with the Arduino?
That's an interesting question. I guess one of the things that worked out very well, I was mentioning that processing tool. So in the end, we were lucky that processing already had quite a big community of designers and artists around the world. And so Arduino became like the obvious way to connect hardware to their software application. So that community gave us a lot of mileage at the beginning. So they really jumped on it and really used it a lot. And I would say The second community, after the students in my class or David's class, there were this sort of the processing community. And I would say the third community that was very interesting for me to see was the people doing electronic music that used software like Max MSP, Pure Data, all these kind of tools that normally, if you look at it, you see people kind of bent over a laptop, so it's not very exciting. So they were thinking, how do I create interfaces with sensors? And before that, there were companies doing that, but they were the tools were quite expensive. So in a way, with Arduino, somebody could build an interface to their Max MSP for only for a moderate amount of money, and they could build interfaces with sensors, with knobs and buttons. That community built a bunch of very interesting sound-based project installations, and so I would say also because of my personal interest, I loved all of the projects that people did when they built installations for events, for museums, or just for fun.
So one of our viewers asks, and this sounds highly theoretical, but they asked, I guess, what you think about hard real-time, supporting hard real-time.
So I have to admit that I don't know very much about this, so I'm not gonna.
I don't either. I'm just asking.
No. I'm saying I'm not gonna start pontificating about something I don't know very much, but it is. So one of the reasons why we tend to include microcontrollers also in every product that we made that ran also Linux. Like, for example, we have this product called the Portenta X8. That's a quad-core IMX8 running Linux. But we also added an STM32 dual-core microcontroller because, I don't know, the people that we work with tend to deal with a very real-time part of their application as like very deterministic code in the microcontroller. It would be so interesting to explore the Cortex-R. Now that we have created this whole new part of Arduino called Arduino Pro that works with professional customers, works with industrial customers. I think more and more of these people will come up with use cases where this kind of application would be fundamental. So at the moment, we don't have it, but it is an area that we should look into it more.
I wanted to ask how you decide what platforms you want to support. So you recently added ESP32 board. I'm a big fan of the RP2040 Arduino. How did you decide, hey, we need to add support for these other chips?
It's interesting because it's a mixture. No, it's a mixture of, in a way, strategic thinking, and sometimes it's just an opportunity that makes sense. No, so in terms of the RP2040. I spoke to Eben Upton, and he told me, "Hey, we're making a microcontroller. Would you guys like to do something with it?" And so we talked about it internally, and we're like, "Yeah, we realized that most of the other products that were about to come out didn't have connectivity, so we took kind of the design of one of our nano connected product, and we said, okay, then why don't we make the first connected RP2040 in an Arduino Nano format, which is a very, very popular format." And so that was, also I really liked the idea that we could do something with Raspberry Pi, with Eben, and on the ESP32, actually, we have been working with the ESP32 in multiple products, mostly as a Wi-Fi Bluetooth module that we use in different products. I have known the founder of Espressif for many years. We meet at a bunch of conferences so in this case, actually, when we launched, we thought, okay, we should make a Nano that's just an ESP32, so that it's like the most basic product that you can think of. That will be connected, in a way, like a connected product first and foremost. And also we got the authorization to call it ESP32, which I know that everyone is kind of, I get trigger happy with other people's brands, but ESP32 is technically a trademark. So we got an official okay from them, and I really like the idea that we could build something a little bit more native with the product. It's also incidentally a RISC-V Arduino.
Ooh.
So although that was not the intent. The intent was to do something with Espressive beyond using them as a Wi-Fi Bluetooth module, to really build something native in a format that we like, that fits in our family. And also, I guess, it's also the chance. So the official Arduino product allows people who want to use that particular platform, but they need, quote unquote, how can I say, a lot of the ESP32 products you find are essentially Chinese boards that come from, AliExpress, whatever. So if you're trying to build something serious around it, you need a company that you can deal with, where you can have a proper business relationship. So in a way, the Nano ESP32 covers this angle as well. No, it gives you like a reputable company with the whole that you can do business with if you want to use ESP technology.
Interesting. So this new ESP32, is that pin compatible with the Nano pin out?
It's all Nano, so it's compatible with any other 3.3 volt Nano. So all the modern Nanos are compatible, and the pins are in the same place as much as possible. It's never possible to do it. For example, in the RP2040, if I remember correctly, the processor doesn't have enough analog inputs, so we had to use 2 analog inputs from the Wi-Fi module to complete the pin out.
Yeah,
it was a bit of it's not a hack. We just had to compensate for some limitation to stay true to the format. So yeah.
So Hakan asks, do you think Arduino facilitates learning programming for novices in computer science?
Interesting. Actually, I've noticed after Arduino became popular, we saw more and more books written by professors that tend to teach the first years of the bachelor in engineering. They were using Arduino as a way to teach about programming, also to teach about computer architecture, because at the end of the day, you have to admit that the AVR is a nice architecture. It's a very simple, pure RISC. I think it's got 35 instructions. So the internal architecture is very simple, very clean. So if you're trying to teach someone about computer architecture, here's a very simple thing that you can program. And so it could also be useful as a way to learn how to program. Some people like the idea of learning how to program by making things happen in the physical world. And so it can be used for that.
I think I learned a lot more about programming playing with boards like the Arduino, because it's hands-on than I ever did in college.
No question. Like my when my son and I wanted to get started on projects together, like the first board we we were doing projects with it when he was like 6 or 5.
Now he's really got a knack for programming.
Yeah.
Oh yes, he has. Yeah.
So Kevin asks, do we know how many Arduinos have been made?
That's an interesting question. So I don't have precise statistic off the top of my head, but when we launched the Arduino Uno Mini limited edition, is because we actually made 10 million official Arduino Unos. So then there you go. That's it. That's the fancy gold and black box.
I haven't got a banana for scale, unfortunately.
Yeah. I wanted to get some Dolce Gabbana vibe in the packaging. Black. And no, I think that is clearly several million. Then obviously there's a bunch of Arduinos that are, there you go. The funny thing is that it actually works. You can actually use it.
It does. I've used this to program an tiny 85.
There you go. No, I think it's the main product, the most popular product was 10 million units. I would say, I don't know, but you can imagine there's several different products. Arduino has about 100 and something SKUs that we make. Then obviously some of them are just the plastic bag with an antenna inside, but still, there's probably 40, 50 boards that we make at least.
Yeah.
So it's in the millions.
Wow. So what do you think? So obviously the Uno R3 was kind of the premier mainstream board for a while, and now R4 has just come out. What made you say it's time for an update, and what do you think people can do now with R4 that they couldn't do with R3?
Yeah, I think there's so we have discussed multiple times what happens after the Arduino Uno R3, where do you take the platform? Because a lot of people still use it. They still use it to teach, to learn, whatever. So there's a lot of there's a lot of people who still like the format. Also, there's a huge install base of shields, adapter, cases, whatever. So the platform is still very, very popular. But obviously, the 8-bit micro, it's limited by nature. The amount of power you can squeeze out of an 8-bit microcontroller is what it is. So in a way, it's almost like when at some point in the 80s, all the home computers manufacturer that were using the Z80 and the 6502, they said, now what do I do? So Acorn invented their own RISC processor. Other people went 68,000, so everyone had to make a jump to 32-bit or 16-bit. So we were looking for a processor that would be an ARM Cortex processor, but there would be 5 volts native, because the 5-volt I/O, it's an important part of the platform. But we also wanted a processor with native USB. So, the general idea was, if we find a processor like that, we can do it. And then, looking at the Renesas product line, we found this processor. It was, good pricing, all the features that we needed. It's okay, let's do it. And then we kind of recognize that right now people tend to want connectivity. So we built a minimal version of the board, which is essentially the equivalent of the Arduino Uno R3, and one with the native Wi-Fi. And then in one of the many random things, we came up with the idea to put a little display on it, because people always, in a way, complained about the fact that there were no outputs on the board. So the only thing was like one little LED blinking. And we thought, these LEDs are cheap. Let's just put them in.
Yeah, that is a really good point. Kevin asks, and I'm curious with this question too, do you see the processing language and community libraries as part of the Arduino experience, or are you more language agnostic?
Oh, well, actually, the whole Arduino and all the other projects that kind of came out of that were based on the idea that, so for me, for example, when I was teaching, they were teaching the intro to programming class with processing. So obviously one of the big debates was, how do we transfer that experience to the hardware, Because we had, you have to imagine, there were a time that back in the school, they were teaching program with Python, and then the next class was in BASIC. So, or even before they were using Micromedia Director, they were using Flash. So, people were learning different languages. And the idea was, why don't we have one language that covers the whole spectrum? And if you think about it, some schools that are in the same kind of they teach the same kind of topics. Even now, they have the same model. So they teach the intro to programming with processing, or P5.js, which is the processing that runs inside a web page, and then they teach hardware with Arduino, and then they take it from there. So in a way, it is kind of a nice progression, so the student doesn't have to switch language. So in a way, that particular, I would say Arduino is opinionated in terms of the way that the framework is designed, the way the language is designed. So Arduino is a framework on top of C++, but the tooling changes the C++ experience. It removes all the parts of C++ that were a nightmare to deal with, like make files and all this kind of stuff.
Yeah.
So literally the idea is that you have to fire up the IDE, select the board from the menu and start typing. That's it. That's what you should do in order to start creating.
That's totally true, because the Arduino IDE 2.0 and the web, the cloud IDE, it's frighteningly easy to use now with board managers, library managers. In the past, you'd be downloading zip files and installing it manually. Now it's all handled in the IDE, and it's extremely simple to use. So it's going to help learners immeasurably just to pick up and use an Arduino.
And teachers.
Yeah. And teachers.
But I see you also now have MicroPython support on at least some of the boards. So
yeah.
How do you feel about that? Do you feel like it's competing with regular Arduino programming, or do you think it's another good way for people to get into the platform?
So I would say, again, I'm very interested in the user experience, and I think there was an interest in figuring out what's the next thing. So there was a lot of discussion over the years. What's the next thing after Arduino? I remember many years ago we discussed creating a framework that would kind of be on top of Arduino, that would be event-based, so that people don't have to do this very procedural, sequential programming.
Yeah.
Then in the end, the classic Arduino worked well for a lot of people, so we didn't do that. But then we realized that Python became the most popular language. Then also in teaching, people are using Python a lot, and MicroPython can make it easier to teach to certain students, because clearly there's no compilation. So you just edit the file, upload it. The syntax is even simpler. So there's no compiler. The IDE is very, very simple. So we started to experiment with MicroPython. And then one of my colleagues, well, it's also one of my friends, who is teaching in basically the same places I used to teach, he started teaching his intro to Arduino, let's call it, class with MicroPython as an experiment, because in the tradition of Arduino, a lot of the things that we introduced into the platform, first we tried them with our students, and we see how it worked and how they perceived it, and then we transferred it to the platform. So in a way, this guy, his name is Ubi De Feo, you can find some videos from him online. So Ubi really tested the whole thing. He figured it out. And then, we realized that maybe this was the direction that we could take. So we contacted the founder of Damien, the founder of MicroPython. We had been collaborating for quite a bit with OpenMV, who does this amazing computer vision platform based on microcontrollers. So they have their own version of MicroPython that actually includes computer vision and AI type algorithms. So it was a natural progression. We even made a product for the Pro part of Arduino, which is an embedded camera, which is basically 1 inch by 1 inch in size, which is completely running on a microcontroller, and uses this OpenMV as a programming platform. So in a way, we explore where the directions go, and we try to evolve with the world.
Well, I know we're running out of time here. I really appreciate your time. I wanted to ask where you see what you think is next for Arduino and for microcontrollers. Where do you think we're heading? Where do you think we're heading next? What are the features that are in demand, or the things you'd like to see on future products?
So at the moment, I would say one of the things that happened that basically also drove the creation of this Arduino Pro platform is the fact that more and more people have been using Arduino in professional application, in industrial automation, in a lot of different tasks. So we created Arduino Pro to follow the people that were using, consumer products in actual professional application. So that particular direction to me is very interesting, is kind of where I come from. I originally studied industrial automation. So it's, I love it. Every time I go to a factory, it's like going to Disneyland for me. So for me, that part is endless. There's an endless possibility. We even launched a PLC, so we're really doing a lot of different things. In the maker world, I think, I think more and more, we always try to follow the user experience. So I think now we have a platform that covers a lot of the use cases, a lot of the direction. We really have to understand what are the next direction. I think one potential direction maybe is to imagine more finished products, or also how to maybe use real-time operating systems in a way that's more understandable by everyday users. So the topics are, and also one of the things I've been working on for the last few years is the tiny machine learning. So running machine learning on microcontroller, that's something that's going to expand. We haven't seen everything there.
Avram, muted.
Oops.
Trying not to make noise. So I wanted to thank you so much for joining us. Thanks so much to everyone for watching and listening. As always, we will be back next week, the 25th, at the same time, 2 p.m. Eastern, 7 p.m. UK time. And we will see you then. Thanks. Bye, everyone.
Thank you. Thank you.